Yes or no? Yeah, Trung Hee, very well. Trung Hee, you are very good at that. Can you read the words that Trung Hee typed?
Từ thông.
The flux of what, Trung Hee? Which flux is this? In this case, I can say, in other words, the current is really the current density flux. It is. The current can be seen as the current density flux or J flux, where J is a vector. I type it in bold so that it's a vector. Okay. Look back to the previous chapter. We have here the phi instead of I. We have phi, right? We have phi. Where's my phi? Phi is EDA, right? Are they familiar? Are they familiar? Say yes by typing number 4, please. Yeah, they are familiar to each other, right? They are twins. Hai anh em sinh đôi đúng không? Mình chỉ đổi cái tên của cái vector chứ mấy, còn cái cách tính là mấy cụ mà. Nhớ chưa? Do đó bạn ý nhớ rất là tốt. Đó là thông lượng. Đó là thông lượng. Vậy thì một cách khác mình có thể nói dòng điện là thông lượng của vector G. Có một cái mặt nào đó. Dễ không ạ? Và như vậy mình hình dung là nhà vật lý, thay vì họ nói dòng điện là một cái gì đó rất là khó hiểu, nó phụ thuộc vào cái gì đó không biết. Bây giờ họ định nghĩa ra cái vector G và họ nói dòng điện chính là thông lượng của vector G đi qua cái mặt nào đó. Vậy thì ở chỗ này, cái mặt này với mặt này, chỗ nào dòng điện lớn hơn? Chỗ nào dòng điện lớn hơn nói cho nghe coi. Cái mặt màu vàng với cái mặt màu hồng hồng á, cái nào dòng điện lớn hơn? Hồng hồng tím tím á, mặt nào dòng điện lớn hơn?
Cái này nhé đâu rồi nè.
Tím hay hồng? Violet hay là violet or yellow? Yellow, pink, violet. Pink is violet, yeah, right? Remember, come back. When the density of the vector is big, right? But you see, in this case, I have only three vector through this area, 3 vector through this area. So I can say, okay, they can be the same, right? They can be the same. Okay, not bigger, not smaller. The flux can be the same, right? Regardless the area. Remember that in the Gaussian's law or Gauss law. Okay, so very well. I'm very happy. Not many students can see the similarity between the two formula here. So I will erase that one. So whenever you have I or J, you can convert them, right? Okay. Now let's look at the conductivity, another term. Conductivity will describe the ability of the conductor for let's say they will let the free charges goes through the environment or the conductor. So when sigma is big, then we say this conductor is good in conducting, in letting the free electron or proton go through. But normally in practice we don't calculate the sigma here. We calculate the resistivity rho. The resistivity rho. You see, rho is reverse of sigma. So normally we take the resistivity instead of the conductivity. But when we use the term conductivity, we can rewrite the Ohm's law. This is the Ohm's law. You already know that. When you apply the voltage delta V on the two ends of a resistor, then the current will be I. So in another way, we can write the Ohm's law like this. So delta V when we apply that, we have I, the current equal to delta V over the resistance R. This is the formula of Ohm's law. Then the resistor can be measured by the resistance of the resistor. The resistance will have the unit of ohm after the name of ohms. So 1 ohm is 1 volt over amperes. Okay, we knew it already. Then if we use terms of resistivity, we can rewrite the Ohm's law like this one. J is sigma E, where E is the electric field inside the conductor, and J the current density vector. The material that obeys Ohm's law are called the ohmic materials. Ohmic material. The materials that doesn't obey the Ohm's law, we call it the non-ohmic. Non-ohmic. Okay, and here is a graph when we apply the voltage delta V to the resistor. When it is the ohmic one, you have the linear as a function of I over delta V. When it is not ohmic, then we have the non-ohmic curve. The curve can be this way, or the curve can have another way, like this one. I can draw another. The curve can be this one. Okay, so some type of the curve. Should not the linear, it's okay. Right? And the physicists will study the properties of the material by drawing this one, and normally we call it the character of the material, or properties of material. Okay, when you study the electronics, you have to read the value of a resistor or the resistance by using the ring here, right? we have the rule for that. For example, when you see a black or the red or green color here, look to this back this table and find, for example, black is 0, brown is 1, and so on. So this is for the first band, here. For the second band, for example, you will take the value, right? So first and second band have the same value. But for the third band here, you have to multiply the value from the first and the second band to the power 10, power of 10 of the color. For example, here you have black is 0, so 0 ohm. Red is 2, so 2 multiply with green is power 5 of 10. So you have here 2 multiply with 100,000. Okay, something like that. The last band here is about the tolerance. It's the error in producing or measuring the resistance. So you have 3 different value of that. When it's gold, so you have here plus minus 5%, silver plus minus 10%, red plus minus 2%, and sometimes you have another color to have 20%, but this is not common. Okay, so for example, when you read that one, you will have the value of here red, blue, green. Red is 2, blue is 6. So you have 26. 26 multiplied with this one, so you have about this one. So 2.6 mega ohm. And here the 4 band is silver, so silver have the tolerance of 10%, so you have this one. So when you have to buy the resistors to develop some circuit, you have to read